Stanford University.
Hey, thanks for coming out today. My name is Chris Flyzak, and I'm on the iOS accessibility team at Apple. And we wanted to come out here and take the opportunity to talk about accessibility, what it means, specifically on iOS. Does anyone know what accessibility might mean in terms of technology? Anyone ever hear of this word before? Go for it.
It means making apps accessible for all users. So if someone is blind, there's a voiceover.
Sure. Right. So it's basically using technology to help people with physical impairments overcome their disabilities to do things that everyone does. So, we have a lot of passion for this. We want to try to communicate that kind of passion to you so that you guys can get excited about this, see that there's a lot of potential here in this field. There's a lot of room for growth and innovation to be done. And, who knows, maybe you'll be developing the next, great app for a voiceover user or someone with low vision or whatever. So before we get started, I'll just tell you a little bit about myself, how I ended up in front of you today. I graduated from Duke almost 10 years ago now. Spent some time in the Peace Corps in Tonga teaching computer science, and came back and got my master's degree. And for the past 4 years, I've been at Apple, including an internship, and I've been working on accessibility in that time, starting off with VoiceOver on the desktop. And then when we geared up and started doing accessibility on iOS, I've been working on that. So I bring that up really just to point out that when I came to Apple, I didn't know anything about accessibility. And a lot of people might hear accessibility, not know what it means, or be a little bit scared of it. And I'm here to say that it's not really any different from any other field in computer science. It's its own sort of subtopic, but it has hard problems just like any other field. With and smart people can succeed. Same as anything else. So it's not extremely difficult. It's just something else to think about and to pay attention to. So accessibility, like we said, helping people overcome whatever disabilities they have. That might mean things like closed captioning for hearing impairments, Zoom if you have low vision, things like screen readers. So if you're blind, often you'll use a screen reader, which allows you to interact with the computer without looking at it. Traditionally, that's meant using a keyboard or something like a refreshable braille display, which is, you got a little picture of that up there. And you use a keyboard to completely drive the interface. You use the braille display to read out what's going on, or you listen to synthesized speech tell you what's happening. So we sort of reinvented that with iOS and VoiceOver in that we have a screen reader that doesn't require a keyboard. It doesn't require a braille display. It's all sort of touch-based. And there's lots of other options, lots of other possibilities for various disabilities. Some things that come to mind for me are people who are paralyzed from the neck down. They have something called like a head pointer, which they'll put on their head, and might have a laser pointer, and then the laser can track sort of like a mouse around the screen. And people can be very effective with these solutions. So there's sort of lots of things out there for a whole range of possibilities. So accessibility at Apple has been really a cornerstone and a priority of the company for the past 5 years. In 2005, VoiceOver, the screen reader on the Mac, came out for the first time, and it's sort of a game changer, because up until then, if you were blind and you needed a screen reader, you had to go out and buy Windows, and then you had to go out and buy something like JAWS or Windows Eyes, which will run in you to the hundreds of extra dollars just for the piece of technology you need to use your computer. So Apple included VoiceOver for free in 2005, and it's the first time we did that. And then we've slowly been adding accessibility options to all the other products out there, including iPods, the iOS platforms, iPad, and then just recently Apple TV came out with VoiceOver on it again. So Apple's really committed to this, and trying to set an example for the rest of the industry in what we should do, and trying to be as inclusive as possible when you make hardware and software. But today I want to specifically focus on iOS stuff. And all of our accessibility options are bundled up in Settings, General Accessibility. So if you have a 3GS or iPhone 4, you have all these accessibility options hidden in there. Just go to Settings, General Accessibility. You got things like VoiceOver, Zoom, white on black, large text, And I'll give you a demo about a few of those in a little bit. But you know, when we first came out with this in 2009, we were a little hesitant about what the reception was going to be because we did things a little bit differently. You know, we had a touch-based screen reader, and there was sort of consternation out there. Maybe blind people don't want touch screens. They don't want to know what the layout of things are. And so we were a little scared until it came out and it got into user hands, and the response has really been astounding so far. You know, we've sort of been blown away by how many people have adopted VoiceOver and how many in the blindness community and low vision are using the iPhone for the first time. And it's not really because, you know, we made a great VoiceOver product. What we did was made a conduit so that someone with a disability could use the iPhone just like everyone else. And that's really what access technology is about at the end of it. You know, you provide a way so that someone can just use the device just like anyone else. So I want to read you a little quote from a website we pulled. Mr. DeLioncourt said when the iPhone came out, "I predict that the visually impaired community will agree that the iPhone was the single biggest game-changing piece of technology for the assist-detect industry in modern times." So that's a pretty bold statement, and I think time has borne that out in most part. The iPhone has been revolutionary for a lot of people with visual impairments. So I'm going to show you a little bit about VoiceOver, how it works. But first I want to show you a short video that came from the Bay Citizen, a newspaper in San Francisco, about an actual VoiceOver user using this.
If you ever take a stroll down the sidewalk with Dr. Joshua Mealy, who has been blind most of his life, don't worry that he'll slow you down. If anything, he's likely to leave you behind.
I'm going to plug in my earphones since we're on the street.
But there's one thing Dr. Mealy won't leave behind, in addition to his cane, and that's his iPhone.
So we got to wait 11 minutes for the 3 jacks, and that's too bad.
With its ability to read aloud text and use GPS for pinpoint accurate location readouts, a single smartphone can replace a gaggle of gizmos that blind people have carried and often cursed for years.
The joke goes like this. How many blind people does it take to cross a street? And the answer is, tongue-in-cheek, 2. It takes 1 to push the shopping cart full of equipment that doesn't work, and it takes 1 to ask a sighted person for help. There are many, many tools that have been developed to help blind people with independent mobility. But if you wanted to carry all of them, you need a backpack or, as in the joke, a shopping cart. One of the really cool things that the iPhone and other smartphones is doing is rolling a bunch of technologies into one platform.
And it doesn't take much coaxing to get Dr. Mealy to demonstrate this platform's potential.
There are 2 different ways that you can navigate around items using the iPhone. You can either touch the item on the screen, Quake Watch, settings. I'm just moving my finger along the icons, and as I touch each app icon, it says what it is.
GPS. Compass.
So that's one way to navigate around the screen. The other way to navigate around is, rather than feeling around on the screen, if you just want to go to the previous and next items, you just swipe left for previous or swipe right for next. So if I swipe to the right,
iTunes. Clock. Not as dark. Sendero GPS.
and it jumps to the next line.
App Store. Weather. Voice memo.
So, or I can go backwards.
Page 1 of 3.
Oops.
Dropbox. Quake Watch. Settings. iMapU. Voice memos. Weather.
Once it says an item, it's selected. So if, for example, I touch,
Sendero GP. Compass.
now that it's set it, it's selected. So I can double tap anywhere on the screen to open that app up.
Compass. 109 degrees east.
This is a really powerful tool for a blind person. If you get disoriented when you're trying to get from one place to another, or if you get turned around in an open area like a park.
Okay, thank you, Dr. Mealy. So, you know, some of our users really are getting into the iPhone. They like it a lot. I'm going to switch over to the device. We can show you how this works, a few of the other options. All right, so like I said, under Settings, General, Accessibility, we have our various options. Things like white on black will inverse the screen for people who need that. We have system-wide zoom, which is pretty useful if you have trouble seeing the screen. So once I turn this on, I can use my 3 fingers to move around the screen and 3 fingers to zoom in and out. So if I tap and push, I can magnify the screen, and then as I need to move around, I can use 3 fingers to drag. So you asked why 3 fingers? It's so we don't conflict with any of the other gestures. So one of the challenges of working with a touchscreen and making access technology is that you need to make it so that it works with everything. And one of the reasons why we're using 3 fingers here. But the meat of our work is focused on voiceover. And that's really because providing access to someone who's blind is probably one of the most challenging problems out there. And if I turn on voiceover.
Voiceover on. Voiceover. Heading.
Okay.
Voiceover. Voiceover speaks items on the screen.
So like you saw in the video, the guy was showing some simple gestures about how to control voiceover. So the first thing to remember is that voiceover intercepts all the gestures on the screen. So if you wanted to touch something, to press it, that doesn't work anymore. Because as you can imagine, if you were blind, you wouldn't want to just touch the screen and then have things happen. You want to know what's going to happen before you do it. So some things to remember.
Accessibility. Back button.
You touch to select with voiceover, and then you double tap to activate.
Accessibility. General.
So
back
I
button.
didn't have to double tap in the same place. I could double tap anywhere because I now have a concept of something that's focused, that's away from what's actually happening.
Accessibility.
So another
Heading.
gesture is flicking left and right. So a quick flick with my finger
Voiceover. Zoom. Large. White on black.
will move from item to item.
Large. Zoom. Voiceover.
I can use a 2-finger tap to pause speaking, so I don't have to listen to everything.
Zoom. White on black.
So I won't continue. So VoiceOver has a lot of gestures that are used to get around. There's a whole VoiceOver manual. I won't go into all of them. But if you want to test out your app and see how accessible it is, very easy to do so. Just go to the panel, turn on VoiceOver, and you're on your way. If you really want to test your skills and know how you can turn on the screen curtain.
Screen curtain on.
And then
large text. Zoom.
See how well you can use a phone with that.
Screen curtain off.
So one thing I should mention is that
button.
There's a triple click home option. And what we've added here is a quick way to turn on and off various accessibility options. So right now it says triple click home will toggle voiceover. If I hit the home button 3 times,
voiceover off.
It will turn voiceover off. I can use the phone again like a sighted user will use it. So I can toggle voiceover on and off. I want to show you a quick app of what is possible in terms of accessibility. So say we're in the stocks app.
Voiceover on. Stocks. Dow Jones Industrial Average. 11,006.02. Down. Minus 46.4.
So what we've done here is, all the relevant, important information is sort of bottled up into one distinct item that you can touch, that you can flick, that you can listen to. So this can apply to pretty much everything on the screen. There's really no limit to what you can make accessible. So even this graph down at the bottom, you might think, oh, that might be really hard to convey to someone who can't see. But what we've done here,
September 1st, 10,320.
is sort of just divide this up and make this into something that can be understood and represented to someone who can't see the screen.
Page 2 of 2. Bowler inaccessible.
All right, so that's the basic gist of this. For most of this presentation, we're going to be making an app accessible, one that is not accessible. It's an app that I designed for demo purposes. It's basically a bowling game that
Bowler inaccessible.
Looks like this.
0.
And the thing that you'll notice is as I drag my finger around the screen, you'll hear this sound which indicates that there's nothing there. There's nothing accessible about that area. If I touch down at the bottom,
switch, button, SM Newsfeed BTN, button.
I get labels for these buttons that don't really make any sense in the context. And so we're going to try to turn this app that's really inaccessible and not understandable into something that's very accessible and usable for a VoiceOver user.
VoiceOver off.
All right. So what are the things we're going to cover today? I'm going to talk about an accessibility overview, really how accessibility works underneath the layers, and talk a little bit about the technology there. And then most of the time I'm going to dive into the UI accessibility protocol, which is the API and UI kit for making an app accessible. So you all have your own apps you're working on. Going to show you how that you can make sure that that works for someone using VoiceOver. And then finish with some best practices that will make your app even better, and then talk about a new category of things called apps for users with specific disabilities. And these apps are really only made possible now that the iOS is a viable platform for people with disabilities. So an accessibility API is really an interface to let another process talk to an app. So another process in this case would be VoiceOver. Now it wants to talk to that app to find out kinds of things. What kind of information do you think VoiceOver needs to know when it's talking to an app? So if you were the VoiceOver app and you touch down at this point, what would you need to know if you touch down at that point? So the first thing you need to know is, what is the item at that point? So you need to touch down and say, what is that thing at that point? Now once you have that thing, you need to ask certain questions of it. What kind of things do you think you would need to ask of that item on the screen? And you can think of that item like a cell in a table view, or a button, or a label. So once you have this item, what kind of things do you need to ask of it? Yeah?
You'd ask for a description.
Description is great. Yeah, that's going to be one of the most important things. Yeah.
What actions does it perform?
Yeah, that's very important. Anything else?
Is it clickable?
Sure, that might be part of the actions, but something that you'd want to know. Yeah?
Hey, Chris?
Yeah.
Repeat the answers.
Okay. So one person said description, also actions and events, and whether something is clickable or not. Anyone else?
What kind of class it is?
What kind of class? So really what the role is, the button, or is it a piece of text or something like that? Yeah, so we want to do things like access to individual items, and then query for status, state, and description. And then once that information is available, you can do things like perform actions and so on. So all of these things, this remote process and all of this is called assistive technology. And that's the term that you'll often hear in this field, AT, or assistive technology. And that basically describes something like VoiceOver, which is going to use this API to communicate and get the data it needs. So to make this a little bit more evident, here we have VoiceOver in one process, an app like World Clock. Someone touches down on the world clock. We say, what's this item here? VoiceOver uses UI accessibility protocol, sends a mock message over to the app through the right frameworks, and says, what's the element at this position? The app does a bunch of work, bottles up this element so it can be sent back across through RPC, through mock again. VoiceOver now has this thing, and it can take the data out of it, things like the description, things like the size of it, and actions and so on, and then do what it needs to do, which is speak what's on the screen. So a little bit about what we have. The Accessibility API was introduced in 3.0, so it's been out for a while now. It lives in UI kit. You'll see a uiaccessibility.h file if you ever look through the headers. And it allows you to provide information to VoiceOver through a standard API. Most of the work in UI kit is already done. So if you're using standard controls in your app, things like UI sliders, UI labels, text fields, that stuff is already just handled automatically. But if you already have custom elements, or you have images or buttons that only have images, that's when you need to start to do a little bit of work to make your app more accessible. So the meat of any accessibility API is all about the attributes. And we got a number of them. Two of them stand out more than anything else. One, is this an accessible element? And two, what's the label? So can someone describe to me what they think is accessibility element is, without just reading the screen and telling me that? What does it mean if something is accessibility element? Don't be shy. Yeah.
It means that if a blind person touches the screen, there's an item there that can read a description and can perform an action.
Right. So basically, there is an element when the user touches a screen that will be returned as this thing that can convey information. So on iOS, if you return is accessibility element for a UI view, that is where the user will touch. It will start at the top UI window level, go down, 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 until it gets to the thing that says is accessibility element is yes. And that is what it will return, and that is what VoiceOver will use to communicate with it. So that's the first most important thing. Is this thing accessible? The second thing, the accessibility label, that's the description of the element. So a pretty clear textual representation of what this is. So two most important things. It's going to get you 80% of the way to making an app very accessible. But we also need something like, how do we know, is this thing selected? Is this a button or an image? So on. So on iOS, we have a way to convey this information through what's called accessibility traits. And this is a bit mask of integers, 64-bit, that you OR together to describe how this thing behaves. So is it selected? Is it a button? And so on. So I'll give you a quick example of how this works. This screen has a bunch of different UI here. At the top, we have something like static text. So this will get a static text trait. In the middle, we got a big image that will have an image trait. We have a button down there, so it has a button trait. And then we have a slider at the bottom, which has an adjustable trait. So all of these things help to convey the right information to the VoiceOver user so that they understand what's going on the screen. Now, like I said, this is also a bit mask of integers, so it's easy to combine behaviors, to use these things with some other traits that may not be as clear right away. So the static text might also have a summary element trait. And this is something so that when this screen appears, VoiceOver knows, I'm going to read this information first, because it's helpful to provide an overview of what just happened to the user, because some context has switched in or out. So the summary element trait allows us to do that. At the bottom, the play button will probably start some sort of media, like a movie or audio or so on. And when that happens, you don't want VoiceOver to talk. So if you adorn that with the start media session trait, VoiceOver knows when I press this button, I'm going to stop talking and let the media play itself. So there's lots of little things like that that will help make your app more accessible and usable by someone else out there. So there's some other accessibility attributes. They're not always needed, but they're still pretty important. Accessibility frame, just where is this element on the screen? Accessibility value. Any idea what the accessibility value is? Quick, tell me before you read the answer. The answer is too verbose to make any sense, so you won't be able to understand in time. So anyone want to venture what the accessibility value might be for? We already have the label, so we know the description.
The actions that can perform.
That's a good guess. Not correct. Yeah. So that kind of information is conveyed in the accessibility traits. So accessibility value is really for elements that have two states, one that might have a label and then the changing dynamic value. So you can think of something like a slider, which might have a label like volume and a value, which is 100%. Or a text field, which might have a label like email address, and then the value, which is chris@apple.com. So the accessibility value provides a dynamic value for some elements. The accessibility hint will allow you to provide a little bit more information about what's going on. So for example, on the main screen, if you touch the icons, it will say, maps. And then after a little bit, it will say double tap to open. And that is the hint that the user has to know sort of what's going on. It's sort of a way for users to bootstrap themselves and understand how to operate an interface. So how do we add this stuff? How do we make an app accessible? Well, we'll start with the easiest way through Interface Builder. And by going to the inspector on an element, there's a tab at the end. You'll see accessibility there. And with that, we can start to modify some settings. So we have things like is accessibility element. It's a checkbox. We have the accessibility label there. We have the accessibility hint. And then a whole bevy of traits that you can select. Now that bevy of traits is not a buffet for you to just take as much as you can on your plate. It's really for you to know specifically this is what it's for. So don't just check as many of those as possible. It won't make the item better. All right, so let's go into this and do a little demo of how to make an app more accessible. So I have the app here. It looks like this. I didn't really show you how it works before, but we select the ball, and then we can throw the ball, and then we get a score, just like bowling in real life. But the problem is it's not very accessible. So the first round is, let's go to the interface builder and see what we can change to make things a little bit better. So the first thing we want to do, these buttons down here at the bottom, they don't have the right labels because they just come from the images. So here we can add labels, like this is settings. Notice how the traits are already selected correctly because this is a UI button. There's a button trait, and interaction is enabled. For this one, I'll call this news. All right, that was easy enough. And then I have some other panels that we haven't seen yet, but we'll make them accessible to see how they work. So here is the settings panel, and I have these UI controls, which don't have any information, so UI control isn't accessible, so I'll need to turn that on, give it the right label, and choose button for that. And then want to do those for the other ones as well. Turn on accessibility, say that's a button. So we have those ones, and now we're ready to see, did we do anything? So if I run this thing, start in the simulator. All right, does that look more accessible to anybody? Yeah, nod your head. Looks a lot more accessible. But the problem is, how do we know? So what we can do, go to settings. We can go to general, accessibility, and we have an accessibility inspector in the simulator. Turn this thing on, and we have this multicolored object, which will tell us information about our app. So if I click here in the corner, I can interact like I normally would. If I bring this thing down, I can start asking information about it. So notice, for this button, the label is settings, the trait is button, just like I added. For the news thing, the label is news, and the trait is button. If we go to the settings again, I have blue color button, red color button, and yellow color button. So that's the quick and easy way to check the accessibility of your program, especially if you're running in the simulator. So yeah, we just made that app more accessible in those 3.5 minutes. So it's not that hard, especially with some the normal controls. A lot of it's just adding labels. But I didn't just come here to tell you about how to add labels. So we're going to dive deeper into this, learn how to add it in the code, talk about some other constructs that will allow you to make almost any app accessible, regardless of how complicated you think it is. So the time comes when you need to move out of Interface Builder and do some more powerful things, and that's when we want to add these accessibility attributes in the code. So if you got a control that doesn't really change, like a play button that's just there, you don't need to worry about, will the label change, will the value change? You can just set those values on it when you initialize this object and then forget about it. So say we awake from nib and we have a play button in a UI control. We just set is accessibility element equals yes, set accessibility label to play, and then move on our way. That's an accessible object now. Is anything wrong with this code? What about the string for play? See anything wrong with that? What if the voiceover user was in Thailand? Anyone? That's right, we need to localize. So for the code examples, they're all unlocalized, but Accessibility comes in all languages, and VoiceOver speaks 30 of them. So make sure you always localize. If your app is localized, make sure you localize all your accessibility stuff as well. All right, so that's the easy example. You just need to set those things, and then that object's accessible. Sometimes you have an object where the values sort of change, and it might be a more custom object. So say we have a temperature view where the temperature changes over time. So for that, once again, we're going to set isAccessibilityElement. What else do you think we need to set? So we know it's an accessibility element, so the VoiceOver user will be able to touch it. That's an object on the screen now. What else do we need to do to describe this object appropriately? OK, accessibility value, really good. What are we going to put in the accessibility value? Yeah, the temperature. So we're going to add the accessibility label, which might be current temperature, and the accessibility value, which is the current temperature. So if you just had the accessibility value, all the user would hear is 37, which may not be enough information to know what's going on. So use the accessibility label, say current temperature, accessibility value, 37 degrees, or whatever the data model tells you it is. So accessibility attributes are going to get you pretty far. It's going to make your app basically 90% accessible. But there's some times when you need to tell VoiceOver that something has happened. And in iOS, the UI is quite dynamic and changing. And this can present a problem to someone who's blind because they don't really know when things have happened. So to tell VoiceOver when things have happened, there are notifications. So in this example from iTunes, say we click on one of these album things. When that happens, we get a whole new screen. All the elements have been switched out. The navigation controller has been pushed over. In that case, we need to tell VoiceOver that the screen has changed. So we can call this method UI accessibility post notification, and then we can call the very wordy UI accessibility screen change notification. And then once that's passed in, VoiceOver will get it and say, oh, screen's changed. I'll play a sound. I'll reset the reset the user, let them know that we're sort of at a new state again. But that's not the only scenario. Occasionally, you'll also find that just a few elements change, or maybe just the label changes, or maybe just an element has moved around. So in that case, it's not really a screen has changed. Sort of the layout has changed. It's just an element has differed a little bit. So say we press this price button. When that happens, it changes to a buy now. So we need to inform the VoiceOver user, in that case, that the layout has changed. We do that by sending the notification. So once they get that, VoiceOver is able to read out the new changes, update its cache, do some other things. There's also a scenario where maybe you have an app that has some sort of data that's dynamic or changing, or you need to tell VoiceOver that something is happening more immediately. And that's what the UI accessibility announcement is for. So this allows you to basically tell VoiceOver to say something to the user. So for example, in Compass, the compass is always changing. When the change is greater than 5 degrees, it will tell VoiceOver to say 89 degrees east, or whatever the current direction is. So it doesn't need to send it all the time, but maybe between just enough so that they know something's going on that's important. You can send out this announcement notification. So let's see how to do this in the code. We can set some accessibility attributes, start to make this thing even more accessible. Any questions so far? I know I'm moving fairly quickly, but there's so much good stuff here, I don't want to waste a second. All right. So what are the things we need to do now? Well, one thing is that this bowling ball is not an accessible object. We can't touch it at all. What else do we have here? In the bowling news, I can't touch on these objects, and this little button down here says the wrong thing. So there's a bit of work here, and what I want to do is first make the bowling ball accessible. We can do that by going to where the bowling ball is initialized and set up bowling ball. Just add the various things that we actually need. So we can set isAccessibilityElement to yes, set the accessibility traits to the button trait, set the accessibility label to the right label, and set an accessibility hint. So now we know that that bowling ball is going to be touchable and operable by the user. So there's also a bowling ball state, which is selected or not selected. So when it's selected, there's no red cursor around it like now. And when it is selected, it has this red cursor around it. So to do that, we need to modify something else. Anybody have any ideas what we do to say this thing is selected or not selected? What kind of attribute do you think we'd change? So I'll give you some options. Do we want to change the accessibility label, value, hint, frame, or traits? That's right. So we'll change the traits. So there's an accessibility trait for selected that we can use, and we'll change that so that somewhere we'll be able to change this selected state. Where's this thing supposed to go? Oh, wrong file. So here is where the ball is selected, and the ball is selected. We'll OR the traits with UI accessibility trait selected, and if the trait is, and if it's unselected, then we'll remove that trait from there using this operation. So now we know whether the bowling ball is accessible or not. One more thing that we can do is change this bowling news table and give this thing an accessibility label. So this will take those table view cells, basically concatenate the information for you, and then return that so that this object, it can now be touched and get the description for and so on. So those are just a few things that we can do. Change the accessibility label, set the traits, make the bowling ball accessible. Let's go ahead and see what happens in that case. So now I can select the bowling ball. It's got the hint that I have, which is align the ball by tilting to the left or right. When ready, select the ball, then throw. So that's a pretty good hint to let the user know what they should do. When I select this, now the trait says button selected. So that's something else that we did. And the last thing we did was add an accessibility label for this table view cell. If I click here, now we have the right label. It says bowling for babies, teach your toddler how to bowl. So yeah, this thing's starting to become accessible by adding a few lines here and there to make this work correctly. All right. So we're going through a lot of this. All we talked about so far is just attributes. Just thinking about what attribute do I need here. Most of the time, it's just an accessibility label, and then your thing's going to work. So occasionally, you have some UI that's really complicated, though. And this is where accessibility containers come into play. Accessibility container is a way for you to represent when you have a view that's very complicated and has lots of stub parts. You want to represent this to accessibility. So easy way to explain this, think about the calendar view. When you got this month view up, in this case, there's one month view, and all the little dates are drawn, and all the little boxes are drawn, and it's done in a very complex way. But what a VoiceOver user needs, they don't need one month view. They need access to each individual day. So the question then becomes, how do we represent that? So in other platforms, this is usually pretty complicated to do this because you need a fake element to represent this object that doesn't exist. Right? So far, all the accessibility we've talked about has been based on UI view. You set this on UI view, it's accessible. You set this label, it's going to work. But when you have something that's not represented in the view hierarchy, you have to return the right fake element or the accessibility sub-element. So for example, we want October 14th to be an object that the VoiceOver user can touch. Likewise, Same thing for October 11th. So how do we do this? So the key is to make something called a UI accessibility element. A UI accessibility element, it merely wraps up all the important data about an object and then sends it back over to VoiceOver to interact with. And now this is not tied to the UI view hierarchy at all, but it lives off of this. So we go window, view, 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 view. We get to this big view, and now this big view is going to start returning these UI accessibility elements. So the first thing we do, we alloc and init this. Second thing, we start stuffing the data. So we'll add in the label. We'll add in the frame for how big this thing is. We'll add in any traits that are needed, for example, selected. And we'll need to store this somewhere. So in this little code example, I've stored this in accessibility elements, which is just an array. So that's the first part to making this sort of fake element tree. Now, once we have that ready, we have all these elements made up, all 30 of them for all the days. Now we're going to have to return them appropriately. So we're going to need to return them from the month view. And the month view is this last thing in the UI view hierarchy chain. And this is going to be responsible for returning its fake elements representing the days. And we do that by overriding 3 methods. They really mirror NSArray, so it's not complicated. We have the number of elements, an accessibility element count, the object at the index, or accessibility element at index, and then index of accessibility element. So they really sort of mirror NSArray, but it doesn't restrict you to only using an NSArray. You can use a dictionary to hold your data. You just need to return those objects. So I'm going to show you how to do this quickly and see how we can make our app better. So where in this app is this appropriate? So if I start touching around, notice I can't touch here. So this frame score looks like a good candidate for using the accessibility containers. That's because this thing is very custom. It's drawn by doing NSString draw at point. It draws some lines and uses CA layers and so on. So in this case, we need to represent these things with some fake elements. So the first thing we'll want to do is go to our scorecard view and add in the sort of framework that we talked about. So the first thing I'm going to have is a method to get my accessible elements. So if there's no accessible elements already, then I'm going to make this array, and I'm going to start stuffing things into them. So here's my mutable array. And now we need to make the accessible elements. I have 3 of them. So I'm going to loop through them and just make one UI accessibility element, init this with the right container, which is self, and then add it to the accessible element array. So with that, let's just see what happens if I do that. Can I touch here? No. Still can't touch here. So there's obviously I haven't done enough work. So there's still a few things missing. One, we haven't implemented the accessibility container protocol. So let's see what happens once we do that. So like I said, the accessibility protocol just returns the element count, the index of the element, and the accessibility element at the index. So now we know that these things are going to be returned. We've made the objects. Will it work with that? And the answer is no. But why? Why are these things still not working? So like I've said, we've made these objects. Here, we've made them right here. We've initted with the right stuff. And we've returned them appropriately. So we've returned them using these 3 methods for the accessibility container protocol. But there's still a lot of pieces missing for this. So anyone tell me, what else do we think is missing? What else do we need to do to return actual objects that are accessible? So what are the 2 things that we always need for an accessibility object to work?
A label.
A label?
And you need
Right. So we don't have either of those ones set. So that's why if I click around in that area, nothing's going to work yet. So what we need to do is add data to these accessible elements. And I think we want to add it here. So at this point, I'll pull out the right accessibility element, and I'm going to set the accessibility label. And I've already calculated the accessible string, which is the frame number, the frame score, whether it was a strike or spare, and so on. So I set this part in, and now I have my label. We can set is accessibility element equals yes, and see if that works. All right, still nothing. I'm clicking around here and nothing's happening. So there's still one more part that's missing to this accessible object. Can anyone guess? I'll give you a hint. It has to do with an attribute we haven't set yet. So think about the attributes I said. I'll run down them again. Label, value, hint, frame, traits. What do you think might be missing that will make this not work? So what if the frame was size 0? What would happen then if you try to hit touch on a UI view that has a 0, 0 size on it? Going to be able to touch that view at all? No. So there's no size. So the same thing goes with these fake elements. Right now, they don't have any size in them. They're all 0, 0. So what we need to do is get the right frame for this object, which is this screen coordinates frame. So VoiceOver doesn't live within the app or doesn't live within a certain view. So you know the frame is always sort of based on a view. Going down the view chain, the frame is always based on that last view. But for accessibility, we need the frame based on the window and the whole screen coordinates. So to get that, I can basically just take my frame, the draw rect, convert it to the window, and from the window, convert it to nil. And those two lines basically will take a rectangle in any view coordinate space, change it to the screen coordinate space. And then I'll set that in the accessibility frame. So now when we try it, and I start clicking around here, I start getting the right frames. So as you notice, frame 1, comma 0. I have some values here, frame 2, frame 3. If I go ahead and bowl, let's see, if I go ahead and bowl a frame, it's going to tell me the information that I want. Frame 1, score of 6, 6 pins. So with just a little bit of work there, we managed to turn this very custom drawn widget into an accessibility object. And like I said, things we need to do to make that work. You make the object, you stuff the data into it, including label and frame, and you return it using the accessibility container protocol. Any questions? So we've gone through all the attributes. We've gone through the containers. Now there's some actions that will allow you to make your app even more usable and more powerful to a VoiceOver user. So accessibility actions allow you to have a custom object and make that custom object usable for someone. So let's take this example of this book scrubber in iBooks. So on this book scrubber, if you've seen this thing, you touch it, you move to the page goes there. Now that's a really hard operation for someone who can't see, because you have to touch exactly on the right page that you want to go to. So instead, VoiceOver offers some gestures, specifically a flick up and a flick down, to change this page by page. The only key is that we have to implement the right action. So the way we do this, we say that this object has an adjustable trait. And once it has an adjustable trait, we need to implement two methods, accessibility increment and accessibility decrement. So both of those will be called by VoiceOver when the user flicks up or flicks down, and then it's up to the app to do what it's supposed to do. In iBook's case, it will move to the next page or the previous page. So that takes care of things like sliders, anything that has a media, duration, a scrubber type thing. And I'll show you an example in the app of where it might also be useful. Another type of useful action out there that we just added in 4.2 is accessibility scroll. So if you have an app like weather, where you have specific cities and you swipe from one to the next. So we know that VoiceOver doesn't allow you to do normal gestures, so you can't do a swipe and expect you to switch over from one city to the next. So in that case, we need to implement a scroll action. And the VoiceOver user will do that with a 3-finger gesture, scroll left and right. But we have to implement the right thing, and that's done with this method, accessibility scroll. It takes a direction that you want to go in. So for example, if we want to scroll left, we catch that case that scrolls left. We say self-scroll left or whatever we want to do that's in your app that will switch the city. And then we post a notification that says, what's the information we want to tell the user about this new screen? So in this case, maybe it's shown Cupertino. Whereas if we go in the other direction, scroll right, we might say, now we're showing San Diego. So that's just another way to control a very customized app. If you have this type of scenario where objects are swiping from left to right, and there's all kinds of instances in iOS. Weather's one of them, but you might also find it on the home screen to go from page to page. So I have a quick demo of how we'd use that in our app, and the location of that is in the settings. So in the settings, we have the ball color option, and then this ball size option. So by incrementing this, I can make the ball size very big. Well, that's too big. I don't think I can lift that bowling ball. I can make it much smaller. There we go. So this is sort of a prime candidate for an adjustable element. Why? Because it has an increment and a decrement, and we can make this sort of really easy for a VoiceOver user to use. So to do so, what we need to do is go to where this object is. I call this the ball size control. I already have a custom object ready. And the first thing we want to do is set this thing up so it's one control. So I won't have two buttons there for the VoiceOver user. Just have one adjustable element. I don't need an up and a down separate button, because usually the more buttons there are, the harder the interface is to navigate. So I have this set up, label, value, and so on. And then once I get that, we just need to implement the right actions, which is return adjustable for the traits, implement accessibly increment, and implement accessibly decrement. And then once we have that, when we check this out, it will be one object altogether with the right label, value, and traits. However, there's no way to perform this increment, decrement action in the simulator, so I'll show you in a demo shortly of how that actually works. All right, so up to now, we've talked a lot about accessibility API. That's sort of generic. We have a label that could be used by anybody, not just VoiceOver. There's also some very specific VoiceOver API you can use to customize your app some more. The prime example of where you might want to do something different if a VoiceOver user is using your app is something like a slideshow where the controls appear and disappear automatically. So when stuff like that happens, it's quite confusing to someone who can't see the screen. So instead, if you check, is UI accessibility VoiceOver running? If it is, just don't hide the stuff. You just leave that on. So that's one of the things that we do in the Photos app and Music app, and that we'll leave those controls running and visible if VoiceOver is actually on. There's some other APIs so you can track where VoiceOver focus is. Accessibility element is focused and did become focused, did lose focus, can track and tell you, right now the slider is the thing that's focused, then brightness is the thing that's focused, the other one loses focus, one becomes focused, the other one loses focus. Very much similar to how the responder chain works, did become first responder or did lose first responder status. So those just allow you to monitor where VoiceOver is. I'll show you an example of how you might use that effectively. So a few best practices I want to talk about before we get to the good demo. I always try to use short and concise labels. There's no reason to overburden someone with long, lengthy labels like adds a city to the list of cities, because someone's going to have to listen to that be spoken a lot. You don't need to include the type of information in the label. If you say, if you add remove city button, does anyone know what voiceover is going to speak if your label says remove city button? That's right. It's going to say remove city button button. And that makes it look like amateur hour if your buttons all say remove city button button. I always use localized strings. VoiceOver works in 30 languages. Another good thing to remember that a lot of people forget is to use localized numbers and localized dates. So if you just put %d in your string and put in an integer, that's not going to work for people in Egypt because they don't use %d. So instead, you have to use NS number formatter. So that's something that a lot of people miss. But if you do that correctly for accessibility, it can work in all the synthesized languages that VoiceOver supports. For custom table view cells, I showed one example in the code. All you do is add the accessibility label. If there's more than one piece of information, like a header and a summary, you really just need to concatenate that data together. So you just use a comma, put those two things together, and then make that one object instead of lots of tiny little objects. That makes the experience a little bit better. All right, so let me demo what this game can look like after we've made it accessible.
VoiceOver on. Bowler. Bowler. Frame 1. Frame 2. Frame 3. 0.
All right, so I hear that. That's what we used. What did we use to make that part accessible? Anyone tell me? I heard someone whisper it. That's right, so accessibility containers. We use containers to make this part accessible. This is where we have a very custom view.
Bowling ball. Button.
We have a bowling ball.
Align the ball by tilting to the left or right. When ready, select the ball, then throw.
So that's the hint that we hear. We also hear a sound. So I'm checking where VoiceOver is focused right now. And if VoiceOver is focused on the ball, I'm going to play this sound. It gets slower when I move to the side. And it gets louder when I move to the middle. So if I was blind, I could use this to guide me to where I want it to be. Lock it into place.
Bowling ball.
And then I can throw it. So, this is not the opportune. There we go.
4 pins hit.
All right. So can I do better than that?
Selected. Bowling ball. Two pins hit. Starting frame 2. Frame 1. 6. 4 pins. Then 2 pins.
Very nice. So let's see. Can I actually play this?
Screen curtain on. Bowling ball.
So I found my bowling ball.
Align the ball by tilting to the left or right. Selected.
Selected. I know it's selected. Throw it.
5 pins hit. Curtain
All right.
off. VoiceOver off.
Oh, and then the adjustable element that we saw.
VoiceOver on. Settings. Button.
We go to settings.
Ball size 1. Adjustable.
So here's the adjustable element. It said adjustable. If I swipe up or down, I can increase the size.
1.1, 1.2, 1.1, 0.9.
So notice it because it's adjustable, it will speak the new value after you change it.
1.8. Done. Button. Score 11. Ball. Button.
So
align the ball by tilting to the left. VoiceOver off.
All right, so that's an accessible bowling game. We turned a very inaccessible game into something that's quite usable. And you too can record your own sounds and then use Audacity to modulate them so they sound like excellent gaming sounds. So I want to take, in the few minutes we have, I want to take a different turn, talk less about the Accessibility API and how to make an app more accessible, and talk about some apps that are for users with disabilities. And this really became a possibility when VoiceOver came out and it started to be adopted by a lot of users. The iPad and iPhone are really great devices for users with a whole range of disabilities. So I just want to go through a few of them. I have some videos we can look at quickly and just say what they can do, and maybe hopefully inspire some of you to think about what kind of app that you can make to help someone else out there. So I just want to highlight 6 apps quickly. There's a whole special education category in iTunes that you can see for apps like this. DigitEyes is pretty cool. It will scan barcodes and tell you what object that is on the barcode. So, if you're blind, you have 2 cans of, you got a can of soup and a can of motor oil. You probably want to know which one is which. You can use DigitEyes, scan that thing, and it will tell you which one is which. So, pretty handy. Say Text is a program that will scan a document and tell you everything on that document just using OCR. So if you're out at a restaurant and you needed to read the menu, you could use this kind of program and find out everything that's there. Omobi is a pretty cool app, not actually designed for a VoiceOver user, but adopted by a lot of them because what it does is object recognition. So it'll take a picture of an object and return to you what it actually is and where you can find and buy it. So give you a short
Here's an update on
demo in this one.
Engine's mobile visual search application. The mobile visual search application is available for the iPhone, but can easily port to other platforms. Using the mobile phone camera, a single photo is enough for product recognition. IQ engines can search through a database of millions of products within a few seconds. This is a quick and easy way to get product information. The application does not rely on text recognition, but rather relies on visual identification. Once the product is identified, the user is connected to product information, reviews, and pricing. IQ Engines uses visual search to tie mobile users to the market.
All right, so that's pretty cool technology that they have going there. I found another app called I Can See, which magnifies whatever you have. So if you got some tiny text there, just put your iPhone over there. You're going to get the magnified version of the text. Pretty useful if you have low vision. iPrompts is a app that I found for people with cognitive disabilities, spread of autism, where it helps you establish routines, let you know when things should happen, alerts, and so on. So quite handy there. And there's a very popular app called ProLogo to Go, which helps people with communication disabilities to speak again. So they can choose, using pictures and text, what they want to speak, and now they have a personal handheld communicator device. So I got a quick video of how this one works.
Hello. This is an introduction to ProLogo.
All right, so
Speak items. You can press buttons, and the items are spoken.
Hi, bye. Hi. Hello.
The words go up into the message window.
How are you?
You can press the message window, and the message is spoken. You can press anywhere along the message window.
Hi, hello, how are you?
You can delete items by tapping the key.
thank you, ProLogo to Go. So those are some, just some, a sampling, a small smattering of what is possible out there now. And there's a large user base of people who are very eager to, to get their hands on this kind of stuff. And it's a very straightforward way to make someone's life a lot better. So summary, if you're an app developer making iPhone apps, think about accessibility. We've made it very easy to add accessibility on iOS, a lot easier than other platforms. It will increase your user base if you can do this. You will get heaps of praise from people. VoiceOver users are very grateful, and they will let you know about it. And it will increase, give you all kinds of karmic improvement down the line. You never know when you might need it. And for these apps designed for users with specific disabilities, I think this is a powerful growth opportunity. There's a lot of room for innovation here, a lot of great research possibilities out there. Certainly there's whole programs at universities focusing on these kinds of things right now. So there's lots of documentation. There's a programming guideline, the reference out there. You can just look at the headers. It's pretty simple once you wrap your head around it. There's not that much that you have to worry about to make a good accessible app. So with that, if there's any questions, feel free to ask. I'll be here. Thanks.
For more, please visit us at stanford.edu.